Hey everyone, welcome to Manual Software Testing Interview Questions Part 6, and in this particular video I'm going to cover another 10 manual testing interview questions which are listed on the screen in front of you. So the first question that we are going to cover is how to approach or how do you approach test case development, what do you do in the test execution, what is entry and exit criteria, what is definition of ready and definition of done. Basically this is more relevant because most of the projects are moving to the agile approach and Scrum, so we need to understand what is definition of ready and definition of done. What do you understand by test closure, what are stubs and drivers and why do you need them, what is black box, white box and gray box testing. So I'll cover all of these with real examples and in detail so you can basically go ahead and explain them in any of your interviews. So let's get started. So the first question, how do you approach test case development? Right now, this is a very common question whether you are a fresher or you have been working in the industry for a while. The approach is not going to change. More or less it is going to remain the same. So the basic approach that any tester or any member in the testing team will follow for the test case development is the first thing is to go through and analyze the requirements, right? So first point that you see here is to analyze the requirement, and when we say analyzing the requirement, you will be going through the user stories, epics, understanding what the business flow looks like and everything, and then based on that analysis you will then start coming up with the scenarios. So the second step, which is basically preparing the test scenarios by applying different test case design techniques. So test case design techniques, whichever are applicable, you will use the maximum of those test case design techniques. For example, equivalence partitioning, boundary value analysis, decision table testing, or the state transition testing. So all of these techniques can be applied in a particular specific scenario based on the analyzed requirement, right? So when you will apply these test case design techniques, your test case or test scenario preparation will become more easy and it will be more efficient and will provide you better coverage. So that's the second step in the test case development process. First is analysis, second is preparation. The preparation work starts, so you go ahead and do the test scenarios and then you elaborate those test scenarios, right? So you can say in the second step as well, test conditions as well, basically anything that can be tested. And similar thing is the scenario, and we say, when we say scenario, it is more of a end-to-end sort of flow, or a not exactly end-to-end but more of combined flow that is more to the test condition, right? So test condition could be a very granular testing aspect of the module. Say for example, you are going to test the calculator, then you are just testing the addition functionality, right? So 2 plus 2 is 4, that is the condition, right? One of the test condition. Multiplication is one of the test condition. But then when you are going to do the calculator or the scenario of addition, multiplication, division, subtraction together, that forms a complete sort of a scenario, right? So it could be 2 operations combined together can be a scenario, 3 operations combined together can be a scenario, right? So depending on what level of coverage you want, you will go ahead with the scenario. Now, many projects, you won't be going into too much detail of the test conditions. You might be, depending on the requirement of the project and the budget that the project has set, regulatory requirement as well, test condition first and then scenarios, and then coming up with the elaborated test cases for those conditions and test scenarios. So that's the basic third step, wherein you elaborate test scenarios into the test cases. So this is the basic flow of the test case development. It doesn't matter you are an experienced person, you have been working in the industry for a while, this is the core process that you will be following. Or if you are a fresher, this is basically what you need to understand and explain to the interviewer when somebody asks you what will be your approach for the test case development. Analysis, preparing the scenarios based on the analysis, and then elaborating those scenarios into the test cases. And in test cases, you will be requiring the test data and everything, and that all test data and all of the details that are required will be anyways be part of the analysis. So when you will do analysis, you will come up with all those details, so you are able to go ahead and document the test cases. Okay, so that's the approach for the test case development. Now what do you do in test execution. So test execution phase, in test execution, testers start executing the test cases assigned to them in the test environment, right? So when we say executing the test case, what does it mean? What does test execution means? So if I'm the tester in a particular project, okay, and it's a banking project, and I have been asked to test the banking transaction, credit card transaction, debit card transactions, and the transaction test cases are assigned to me. So in that particular scenario, what I'll do is I'll go ahead and then take a dummy card or the number, the card number, the test card numbers, and then I'll start going through in the test environment wherever that particular transaction capability is available, right? So in production, when you are going ahead and doing the transaction, you are going to some particular shop, right? You are going to, say for example, you are going to McDonald's for some food, you are going to some other shop for the food, you are going to some shopping website to do the transaction, right? So based on that, you will tap the card, you will enter the card details, and the transaction should go through successfully. But in the test environment, how you are going to make sure that the transactions will go through when this particular code, the transaction code, will be deployed in production as well. So that is what test execution phase is all about. So if new functionality, new feature has been developed and it has been assigned to a tester, that feature will be deployed in the test environment first. Okay, that will be available in the test environment. That is only available to the internal team and the testing team to test. Before, after testing has been complete and everything is working fine, then the production deployment is made and it is available to the end customer so that they can go ahead and tap the card, insert the card, put the card number, and do the shopping accordingly. So to take that example in a little bit more detail, so in the test execution, the transaction, in the test environment, all the transaction test cases that are assigned to me, I'll go ahead one by one. I'll say, for example, verify the transaction or validate the transaction goes through successfully for this particular card at this particular kiosk or this particular merchant, right? So the code and everything should be proper. So I'll go ahead in the test environment and put the test card and ensure that when I trigger that transaction is basically going through successfully. It is recorded successfully into the database. I'm able to see the transaction record of the amount that have made in the test environment, and that data, that amount, that code of the merchant is basically logged successfully into the database, right? So that is what testers do during the test execution, and this is one part of it. This is just transactions testing, right? Now you could be testing something else. So in a high level, what you do in test execution, you take the test cases that are assigned to you as a tester. One by one, you go ahead and follow the steps that are mentioned in the test cases and launch the application, or go ahead and follow those steps and ensure that the outcome is as expected, right? So that's what is done into the test execution. Okay. Now, what is entry and exit criteria in software testing? So entry and exit criteria is very important interview question. Entry and exit criteria, as the name itself suggests, so when you want to enter some phase, and exit is when you want to exit a particular phase, right? So entry criteria is nothing but a checklist, you can say, or a criteria that is being defined that helps you to decide when you can basically start the testing for a particular testing phase. For example, when can you go ahead and start the test execution of the functional testing, right? So what is the criteria? The criteria should be basically that your build should be ready first, right? You can't just go ahead and things are not ready, your application is not ready, and can you go ahead and start the testing? No, right? So entry criteria helps you to identify the key details or key checklist or key items that need to be completed before any further work can be performed. Okay, so that is what the entry criteria is all about. So entry criteria can be applicable to each and every phase, right? So it could be applicable to the requirement phase, to the design phase, to the development phase, to the testing phase, right? And this was more of when the traditional development approaches were there. So entry and exit criteria was more relevant in the traditional development approaches, waterfall and V model, and it is applicable nowadays as well in agile, but with a different terminology. So I'll explain that as well. So entry criteria will help you to identify when you can enter a particular phase. For example, to enter a development phase, the team needs to have the design completed, right? Or design discussion happened, and they need to understand how they are going to progress, what the design will be, and what they need to go ahead and start coding. That's the entry criteria. The exit criteria helps you to decide when to stop the testing, when to stop the development, right, of a particular phase. So that's what the exit criteria is. And entry and exit criteria, when somebody asks you in the interview regarding the testing, it's mostly relevant to the testing, right? So, but it could be applicable to other phases as well. But if you are giving a software testing interview, it is mostly when you can start testing and when you can stop testing. That's the exit criteria. So starting testing, when you can start testing, is the entry criteria. What is the criteria that needs to be met when you can stop testing? That's the exit criteria. Okay. And exit criteria from one phase forms entry criteria of the other phase, right? So for example, when we say, when can you start the integration testing? When all the unit testing has been completed, right? And no major defects are outstanding, right? So this could be one of the criteria. There can be many points in there. When can you start when can you start system testing? When integration testing is all completed, no major defects are open, all the defects that are all severity 1 and 2 defects that were there in integration testing have been fixed. Then you can go ahead and say, yes, system testing we can go ahead and start because integration testing has been completed, right? When can you start acceptance testing? So the exit criteria of one phase forms the entry criteria of the another testing phase, right? So that's the third point. Now the next question, what is definition of ready and definition of done? DOR and DoD. Okay, now this is kind of similar. This is more relevant to the agile and scrum. Okay, and definition of ready, you can understand this as the entry criteria, and definition of done is more of a exit criteria. That's the correlation. The names have changed, but it's similar, serving the similar purpose. So when we say definition of ready, it is the checklist or the criteria of what needs to be done to a product backlog item before the team can start implementing it in the next sprint, right? Now in the agile approach, in the scrum, the phased approach, everything is there within one particular sprint, right? So everything needs to be done. Design, development, testing, all the applicable testing, whether it's unit, integration system, everything needs to be done within that particular 2 to 4 week cycle. So that is why instead of having the same entry and exit criteria, the definitions have changed in Scrum, and it is definition of ready and definition of done. So definition of ready, when we say, it is more applicable to the product backlog or the requirement or the stories that are there in the product backlog, in what state those product backlog items should be, so that team can go ahead and start implementing them, right? So in agile, you have the product backlog, which is the high level product requirement or the project requirement that need to be built, so that we can say that yes, this is the product that we are building. And then from that, there will be a small chunk that will be picked up, and that will be part of the sprint backlog. So when the team will pick up those small chunk, couple of user stories, 4 or 5 user stories for a sprint, in what state those user stories should be, so that they can go ahead and straight away start building. They should have clear-cut requirement. They should have the acceptance criteria defined. There shouldn't be any ambiguity, right? So these are some of the points, some of the checklist items that will be defined for the item or for the user story or product backlog item to be called as definition of ready, or to be called as ready, so that that particular user story can be picked by the team and they can start building it. So they don't go ahead and then again have some ambiguities in there. When they read that particular story, they are not able to understand what needs to be implemented clearly. So all the acceptance criteria, any detail, any questions that are outstanding for that particular user story need to be completed, documented in that particular user story, and it should be absolutely ready to be built. That's what definition of ready is. Okay. When we say definition of done, now definition of done is again a checklist which you can correlate with the exit criteria, and it is a checklist that defines when a product backlog item is considered done. When do you consider a product backlog item or a user story that yes, it has been done? So development has completed, all the testing has completed, there are no outstanding defect, right? These are some of the checklist item again for the definition of done. That story has been showcased to the stakeholders have accepted it, right? No further changes are required. So these are some of the checklist items that that will be mentioned in definition of done. And once all of these items are satisfied, then you can consider that yes, we have completed this user story as part of this sprint or future sprints, right? So this is what definition of ready and definition of done is all about. Okay, so in short, you can see that there is a very close correlation between entry and exit criteria, but definition of ready and definition of done are more relevant in Scrum and Agile development approaches. Okay, and this checklist can be updated by the team. So it is developed by the team and it can be updated to add more points to this particular checklist as and when required. It's not hard and fast fixed sort of checklist, right? So it can evolve over the period of time. Maybe in the initial development phases, you do not want to have that strict criteria for definition of ready and definition of done. But as your team matures, as you start working and you have a defined level of maturity in the team, then you will have a strict definition of ready and definition of done criteria. So you can update the checklist as well, and team does that. So team collaboratively discusses and does that. So that's the definition of ready and definition of done. Now 55th question, what do you understand by test closure? Very important question. It's applicable whether you are working in the traditional development approaches or agile. So test closure, as the name suggests, it is basically when do you close the testing, right? So test closure is about collecting all sort of data that is there from the completed test activities and preparing a consolidated report. So it's also known as test summary report or test completion report, TCR or TSR. Many synonyms are there. Okay, but the crux is test closure. So when the testing has completed, the lead or manager will basically go ahead and get all the details of the testing activities, prepare the test summary report, what has been done, how many modules have been tested, how many test cases have been executed, pass, fail, all of that goes into the test summary report, and that is what happens in test closure, right? So once you have created the test summary report, test closure, right, test closure report, after that you also not only just preparing that report, you also ensure that all the whichever planned deliverables have been delivered. So what all deliverables were there, committed, test strategy, plan, test cases, etc., what has been delivered, what all incidents or defects have been reported, how many of them fixed and resolved. So all of this becomes part of the TSR, test summary report or test closure report. And then another part of the test closure is to finalize and archive the testware. When we say testware, it's your test cases, test scripts, test data, any further testing document or artifacts need to be archived, and all of that information needs to be available into the test summary report, that this is where all the artifacts and other details are there. Okay, the test case, where the test cases are, where the defects were logged, what is the status of the defect, what's the defect dashboard, what is the test case dashboard, test execution dashboard. So all of that detail need to be archived for final use and also mentioned into the test summary report. So when somebody goes ahead and opens the test summary report for a particular project, they are able to see, yes, all of this testing was done. These were the test cases executed. I can find these test cases at this particular location. These were the defects log. I can find defects at this particular location. So all the relevant documentation and artifacts are available just by going through the test summary document. So that's one part of it. But test closure is a broader term which involves preparing the test summary report and also all other closure activities, for example, archiving or finalizing the test cases, scripts and everything for future use. So that's what the test closure is all about. Now 56th question, what are stubs and drivers? So another very important question, and in the real scenario, in your practical testing in the project, you will definitely be going ahead and using stubs and drivers, because all of the product functionality doesn't become available on day one, right? So the software development is an incremental process, so not everything can be available at day one for you to test, right? And especially in Agile and Scrum, so you have to understand what stubs and drivers are. So stubs and drivers are nothing but the dummy code. Okay, so it's a throwaway code, dummy code, which is used to replace missing code or component during testing. Now, because say for example, you have a module A and module B. Module A is ready, you can test it, right? right? But that module A depends on module B. Now module B is not ready yet. So will you go ahead and wait for module B to be ready to start testing? That's not the ideal approach. If module A is ready, it's always good to go ahead and get the testing started so that if there are any issues in module A, they can be basically uncovered early. So that's where stubs and drivers help you a lot. And stub, so if for example module B is not ready, it can be stub, it can be a stub or can be a driver depending on whether it's called or it's calling. Okay, so stub is called from the software component. So for example module A, okay, is calling module B, right? So when module B dummy code is written, because it's called from module A, that is stub. Okay, so module B code is stub. Now module B code is ready, right? But module A is not ready. So module A will be a code will be written, dummy code will be written for module A, and that will call module B, and that module A code is a driver, right? So stub and driver are both dummy code, but the significance depends whether the module is called or calling. If it is calling, it is a driver, right? So a driver calls a component to be tested, and stub is called from the software component. In a real scenario, when I say for example, I have the UI component, UI which is ready. Okay, so UI page is ready, wherein registration page is ready or the login page is ready. Okay, but actual login functionality, the business logic is not ready. So on the UI, when I go ahead and click on, say for example, register button, so it will open a page to do the registration functionality. I'll provide my name, my date of birth, other address details, and click on register. So ideally that whole data that I have filled in that particular form should then call the registration module, right? But registration module is not ready yet. So what can we do to test just this UI that is ready, the error messages on the UI? What can you do? You can basically you can write a dummy code which acts as a registration module and just sends dummy responses. Nothing, no business logic, right? So just throw away code, just sends. If somebody clicks on register on the UI, it will just send the response back that registration successful. So you can verify or validate that the registration successful message appears properly on the UI. Okay, so now what this component, the registration component that has been stub, what is this called? It is a stub. Okay, the dummy code is stub because it is basically called from the software component, which is the registration functionality, right? Now same scenario, UI is not ready but registration module is ready. Okay, the module is ready. How you are going to test it, right? So in that particular case, you are going to basically go ahead and write a dummy code which is basically a driver, and this is done by the stubs and driver development is done by the developers, not the testers. Okay, so you will be getting help from the developers and they will be writing the dummy code for it. Okay, because mostly they would have done it already for the unit testing, so they'll just pass it on to you guys. Now the UI is not ready, so a driver is written which you will use to call the module that is ready, which is registration module, and you will pass on all the attributes through that driver and ensure that the response registration successful is actually received from that particular module that is ready. Okay, so this particular component, when UI is not ready and you are writing a dummy code to simulate that is basically a driver. Okay, because it's calling the module that is ready, and the ready module is registration module. Okay, so this is the real example of stub and driver or stubs and driver that you can use in your. Okay, now let's move on. Why do you need stubs and drivers? Okay, very important question. Now we have understood about the stubs and drivers. We need stubs and drivers so that the teams can start early testing, right? Early testing principle, one of the software testing principle. You need to start testing early so that you can uncover defects early in the phase and team is able to rectify those earlier rather than waiting for those when everything is integrated and you are trying to figure out all the defects as well, right? So that is why stubs and driver help teams to start early testing. Another thing, stubs and driver help testing team to test available modules by replacing missing components with stubs and drivers. Same thing that I explained with the practical example in the previous question. So missing modules can be easily replaced and you can test the modules that are available by usage of stubs and drivers. And stubs and drivers make testing process faster. Why? Because you start early, so you are able to test the modules earlier, and when everything is being tested earlier, and as and when it is available, eventually the integration testing and the system testing, when you proceed to that particular phase, you will already have tested most of the module at the individual level, and that will help you to expedite your testing in the later phases of the software testing lifecycle. Okay, so that's the benefit of stubs and driver. Now, 58th question, what is black box testing? Okay, so black box testing is the input output driven testing. Okay, it's a black box, as the name itself says, a black box. Now, when I say go ahead and test a phone, I give you an iPhone or an Android phone, go ahead and test it, right? So what you will do, you will go ahead and turn it on first thing. If it is turned off, go ahead, turn it on. You will see whether it's turning on or not, right? So once it's turned on successfully, you will go ahead with the registration, the overall customer registration process or login process, and then going ahead and seeing that yes, you can insert the SIM card, you are able to make the call, receive the call, send the text messages once the SIM card is inserted or not. You are able to connect to the Wi-Fi and browse the internet, open the browser and go ahead and browse the internet or not. These are some of the very high level testing that you will do. Now, do you know or do you have any visibility what happens in the background when you press that button, the turn on button, the power on button, right? You don't know anything what happens in the background when you press the button. So internal working of that particular phone is a black box to you, right? You only know the button you have pressed on, you know that this is the power button, it will power on the phone. So when you do not worry, you do not know what happens inside the phone when somebody presses the power on button, when somebody opens the browser, when somebody connects to internet and then browses the internet. Internally what happens, what signal is being triggered, what all network connectivity happens. When you are not bothered or worried about any of that, that is black box testing, right? So black box testing is concerned about what software does and not how it does. You are not concerned about how that powering on happened, how the battery is providing the power, right? How the connectivity happens. You are not bothered about that. You are just bothered about the functionality. So it's a black box to you. In the software testing context, software context is the same thing. You are testing a, say for example, e-commerce website. Okay. So you will go ahead and open the website. You will click on register button. You will provide all the details. Click on register button. You will see that registration has been successful, right? You are not bothered how the internal code works when somebody submits the registration form. Okay. How many methods are called, which statements have been executed or not. So that's what the black box testing is, when you are not bothered about any of the internal workings of the software. And in the black box testing, you are testing both functional and non-functional aspects, characteristics of the software. And black box testing is dynamic testing technique. When we say functional and non-functional, functionality is registration functionality. Non-functional aspect of the same functionality is how quickly the customer gets the response back when he clicks on register button. That's the non-functional characteristics, right? I'll cover in more detail in upcoming questions about non-functional characteristics and functional characteristics as well. So that's what the black box testing is all about. Now, what is white box testing? So as we have understood about the black box, so white box testing is when you are, say for example, testing a phone or software, when you are worried or when you look inside the software structure, when you see, when I press the button, what all has been triggered, what signals has been transmitted, how the battery is providing the power, whether it is providing the right set of power so that the phone doesn't get damaged. All of that testing, the internal structure, the internal working of the phone or the software, right? So phone, I'm taking the context because it will be easier for you to basically understand. So in the software context, when I click on registration functionality, what all methods have been exercised, what all methods, what all classes that developers have written to implement that registration functionality, how many of them have been called, how many lines have been executed. So when I'm testing that, that is basically white box testing. White box testing tests how decisions and conditions are exercised, unit test cases are developed to exercise loops decision. When you say unit testing, it is basically a white box testing. And unit testing or white box testing tests the path within the unit and also flow between the unit. So it's just within the unit, integration between the unit, and white box testing will require internal code structure and programming knowledge, right? So you can't, as a tester, you can't test it if you don't have programming knowledge. And mostly unit testing will be done by developers. It very rarely, I haven't seen that unit testing is being asked to be done by the testers, right? So developers who are writing the code, they'll do the unit testing and then they'll pass it on to you. So white box testing is just there for you to understand what exactly it is, but most of the time you won't be going ahead and doing white box testing and white box testing is also a dynamic testing technique. So both black box and white box testing testing are. So last question for this particular video, what is gray box testing, right? So we have understood about black box, white box. Now gray box should be, from the name itself, it's clear, right? So neither white or neither black. Okay, it's in between. So it's a combination. Gray box is a combination of both white box testing and black box testing, right? When you are doing the functional testing, right? So you are also following the black box testing approaches, okay? And then also looking at a little bit into the internal working of the code. If there is a combination of these two, then you are doing a gray box testing. And it's a software testing technique to test a software with partial knowledge of internal structure of the application, right? So you don't need 100% knowledge of the internal structure, but partial knowledge of the internal structure and the black box testing technique combined together is what gray box testing is. And most of you, okay, as you progress through your careers, you will be ending up doing gray box testing. Why? Because you will be doing API testing, which will require you some sort of knowledge around the APIs and how the APIs or the business logic is being implemented, a little bit around that. And then you will be also doing a lot of functional testing. You will be doing automation as well, right? So there will be a combination of white box and a black box, not a complete white box. A complete unit testing will be done always by the developer. That's personally my experience. I'm not sure if some of you, if you are experienced, have ever done unit testing in your projects. If you have done, then you are more of a developer and not a tester. That's my personal experience. If you have been asked to do that unit testing yourself, but yes, API testing and the black box testing. So the combination will be gray box testing. Combination of white box and black box is what you will be involved heavily, and most of you will be doing gray box testing in your project. So that's what basically the gray box testing is all about. So that's all for this set of 10 questions. In the next video, I'm going to cover another 10 manual testing interview questions. Please go ahead, share this video, subscribe to the channel for more interview questions. This is about manual testing interview questions. I'll be covering a lot more interview questions around automation, Selenium, other automation tools, Java, Jira, etc. So that's all in pipeline. Go ahead, share as much as you can so this knowledge can reach to maximum number of people and is helpful for us. So I hope this was helpful. Thank you very much.